This is Todd Booth, and I've had to make some edits to the Adobe Connect Pro version, and unfortunately, it's a not a good format to work with, so the resolution is low. There's nothing I could do about it when I needed to make a small edit. Okay, thanks. Here we go.
Okay, welcome. We are online, coming live from Shaleftio to the Internet Security Guru team, the Dream Team. Hope everyone's well. So, what's everyone been doing? What have I been doing? I've been doing a lot of this ASA security stuff, so I'm like learning all the commands for, I'm mastering VPN client to it, I'm mastering site-to-site VLANs. There are some issues that come up and things don't work exactly the way I'd like right away, so fast. One of the things I'm doing is I'm also using the ASA, the Cisco ASA to connect to the Viata. The Viata is a virtual router. It's really popular. It's free. It's free. There's a free community edition. It's not open source though, but and it's been purchased by Brocade, and that's a great one if you need a virtual router, firewall, security device, VPN server. And then I've been connecting that to the Cisco ASA. So I got that down real good. And what I've also done is receive some more ASAs, and I'm starting to put them online. So today I can be very happy to tell you that I've got an ASA that you can use and you can destroy. Because I've got a saved copy of the config, so you can just destroy the config and test anything you want. And you can test like clients coming into it, and you can site-to-site VPNs. And what I'm looking at is the course book and schedule right now. And next week is the big week where you get into IP security. And that's going to start on Monday, and that is awesome because that's what I've been using this ASA for, is to create all these labs and demos, and that's where it fits in the book. In Chapter 9, we talk about IPsec, IKE, ESP, and then you'll have all the demos and you'll have equipment available to configure it all. Okay, well that's that. One sec. Okay, let's see. And then this week we've got the electronic mail. Let's talk a little bit about electronic mail. Okay, I see some people typing. Good. Go ahead and if you have topics to talk about, great. But electronic mail is awesome because it's one of the killer apps. It's this huge. We all use it all the time. There's a bunch of security issues with it. You know, when I'm talking about creating these site-to-site VPNs, there's other ways to do it. You could have a lease line, spend more money, but there's different ways to do things. And that's kind of more of the security engineer backside, what you do in the backside to create the infrastructure for the organization. But when we talk about electronic mail, that's like a huge application that all users use. And there's all kinds of vulnerabilities with email. And, I mean, you can't stop email also. So let's talk about it. Well, I'll set the stage. That's what I'm doing. I'm going to set the stage, and then you're going to pop in your suggestions for critical thinking discussions. The Chapter 8 is talking about pretty good privacy, and that is awesome. Zimmerman has just done a fantastic job for like a low budget, for a garage budget, and he's just had some very smart ideas, and the book does a great job of talking about that. Then the book talks about S/MIME, so that's a bit of a competitor to PGP, and S/MIME, wow, there's a lot to it. I was reading the book. It's like this email it's like a complex XML document, if you know XML. And it has a whole bunch of different functionality. It's got the messages and the certificate processing, very important. And it's got enhanced services. And then we've got this idea of the domain keys identified mail. Okay, now that is a really awesome, smart idea. And the idea is we send out the email and we set up our domain, our DNS records. And what DNS records are, domain name service. And what that is we have if we want to connect to a host like whatever, cisco.com, we type in cisco.com, return. Behind the scenes, our PC will take the symbolic name, cisco.com. It's going to go to a server, and the server will give it the IP address equivalent, something like 130.240.1.2. And then the PC browser will try to initiate a TCP connection based on the IP address. So that's DNS. That's like the basic for domain resolution of symbolic names to IP addresses. But there's more to it. There's also for electronic mail, we have some information in the DNS server which says, if I'm trying to send email to a user at cisco.com, what host do I send it to? And it doesn't do a direct translation from cisco.com to the IP address. For electronic mail, it'll look up these special mail server records, and then it will have not only one address, it might have a couple with different priorities. Now with domain keys, what we do is we stuff into that DNS server. So for example, my domain, or one of them, is toddbooth.com. So I go over to my DNS server, and I configure in the DNS server this domain keys, and I put special cryptographic information in there, and I can say that this information means that I have a valid email. And then when people receive email from toddbooth.com, what they do is they look in the email itself. They look at if there's this domain keys identified mail within the email, and if there is, then they go do an independent DNS query, hopefully via DNS security, to get information from Todd Booth's name server, and then they compare and they see if it's the same, and if it is, then they assume it came from Todd Booth. And if it doesn't match, then they assume it came from a spammer. So that's the idea of that, and it's a really awesome solution. And for example, Google has that solution, and if you go to google.com and you have your own domain hosted there, you can configure this. Hey, maybe it'd be even fun to do it. You can configure the domain keys within Google. So I might do that as a demo to show you how. Then the book has the recommended reading as always, and if you're interested in more, I mean that's a great place to look. I'm looking at recommended reading. It's from 2007, which is a little bit old, but it is DKIM. So that's one idea. Okay, well, there you go. There's a summary of the chapter. Now I'm ready for your great suggestions on critical thinking. Okay, well, here's what we're going to do. I'm going to pick on you, and I'm going to quiz you, and we're going to discuss things until such time as you come up with your own suggestions. So here we go. PGP. I mean, 8.1 section is just an awesome idea, but it's so simple and brilliant. What he did is started with the best available cryptographic algorithms. You know, why choose all this old junk? And remember, when you're trying to solve security problems, you have to think about what problem you're solving and what the environment is. So Zimmerman was trying to solve the problem for the average user. The average user who's perhaps not in a corporation, not in a university, they're on their own, and what they want to do is have secure email. They want to have confidentiality and integrity. And they also may want to have the same for their file system or their files. So for email, we have to think, we're not going to have some high-performance hardware, and we're going to normally always do it in software, normally, I mean, at least until the last few years with AES hardware accelerated performance with Intel. So he just needed to have some solution that would work with software, which would work well, and he just picked the best and the most current ones of those. And then he was thinking he doesn't want it just to work in the U.S. And the U.S. has these export restrictions for security, and they used to be really tight, and they're getting looser now. And what he did is he tried to figure out what kind of security he could develop and put together in a package which would be exportable from the U.S. Okay, and then this is okay. The book does a great job of this. He also entered into an agreement with a company where a company could resell it, because companies, when they buy things, what do they want that's different than users? They want support. They want to say, if it doesn't work, who do I call, and will they fix it and create a new code? And in the open source community, it might be really great, and you run it in your company, and everything's fine, and then one day you have some problem, and you find some limitation in it, it doesn't work, and then you contact the open source group, and you ask them to fix it, and they say, sure, but what do developers do when they're developing for free? They usually enjoy much more doing new, fun things instead of supporting old legacy code. So they don't really care as much as for fixing old problems that may not affect many users. They're much more interested in applying the next generation of security and things. So that's a problem with open source. And what they'll tell you is, hey, it's open source. You've got the source. Go fix it yourself. So what companies say is, if we're going to run this in a corporate environment where we're going to depend on it, we want a vendor that we can go to and they'll fix it. And that's what Zimmerman did. He created this agreement. And the good news is there are open source packages out there, and you can quite often find a vendor who will support you with that open source. They don't own open source, but they'll support you. So that goes good. And they have, you can see the Zimmerman stuff's based on IDEA, TripleDesk, SHA-1. Boy, as I remember, he got into some trouble because he exported some of this cryptology information without permission from the U.S., but that's another story. That doesn't matter too much for you. Okay, and it's really cool the way the authentication works for email. I mean, what they're doing is he's sending an encrypted session key. We'll call it a session key for the session of the mail, encrypting that with the receiver's public key, and then encrypting the message. And the receiver should know their own private key. Then they can decrypt the key and use that to decrypt the message. And he does have a variety of different functionalities. He's got the digital signature, so you can verify the authenticity of the sender. He's got the message encryption, so we can have the confidentiality, and you can use a couple different algorithms for that. Then the compression. Okay. And here's something I don't think the book did a good job on. What is the advantage of encrypting first and then doing compression, or compression first and then doing encryption? I mean, what's better, encryption and then compression, or compression and then encryption, and why? And the book talked about some reasons, but I have my own also to add with my own critical thinking. Okay, we have one answer. Does anyone have another answer? Does anyone have encryption and then compression? I might be trying to trick you. Yeah, okay. Daniel, okay. If you encrypt after compression, you don't send plain text. It is already scrambled. Yeah, I mean, that's true, but if you compress, it's not confidential. It's scrambled, but it's easy to break and hack. Because compression is just a reversible algorithm that's public knowledge, and it doesn't involve a key. It's not like encryption. So, okay, now, I didn't give you the mic. We've got one. Okay, where we go? Okay, Daniel has the mic. So you can text chat, or you can talk in the mic, and I need to know, why exactly is it better to do one way or the other? And Daniel's answer is good, but not good enough. You need to, there's the reason the book talked about, and there's the reason I have in addition to the book. Okay, James, that's very good. And then what's the result of that? What you said a very great point. That's what I was thinking of. But what's the point? I mean, how would you describe it in another way? Anyone? You're not reading my mind, so I'm just going to say it because maybe it's too hard to read my mind. James is right on, and that's exactly the point I was thinking about that the book didn't talk about. And the result of, if you compress first and then encrypt, then there are more patterns and things in the text. And what that means is the compression ratio will always be higher if you compress and then encrypt. If you encrypt and then you compress, we say you will not have a high compression ratio. So, for example, if you have, let's say, 100K text, if you compress first, maybe you'll get 30K and then encrypt. But if you do it the other way around, the encryption, instead of bringing it down from 100 to 30, it'll bring it down from maybe 100 to 50. That's the point. So it's not as exactly, that's exactly correct. It's not as efficient. Right. It's not as efficient. And you know, I'd be interested in numbers, but it might be more like 30% when you're compressing a normal text email from 100 to 30, and then maybe it's only like 80 or 90 if you're going to compress after encryption, because you're right, encryption tries to make it look random. Not good when you're trying to compress something. Okay, well that was good. So we did a little deep dive on that, and we found some information that's not in the book. However, what's in the book? I mean, what you did is you did a great job of finding my critical thinking, which was not even in the book, but there's some reasons in the book they talk about too. So if you read the book and listened to my lecture, you would know. So what's the other reason? No, the issue is not all compression algorithms will work in an identical way. So it turns out that it's better to compress and then encrypt. Because after you encrypt, you'll always have that compressed data. But if you encrypt and then compress, you'll have different amounts. So it's better that way. Yeah, so you can have different algorithms that aren't going to do exactly the same thing. It'll work out fine if you compress and then encrypt, but it won't work the other way. You'll have a different amount of data otherwise. So that's good. So anyway, and the book goes into detail on those, so I'm not going to. Oh boy, when you look at the confidential, now you can use PGP for confidentiality, for authentication, or for both. And they talk about some nice algorithms for that, and you should be able to follow the algorithms. And actually, you should know the following. I mean, you should know this really well by now. Okay, you're going to answer the question, and I'll tell you when to enter. Everyone has to answer via text chat. Here's the question. If you want to send a message, an email message, and you don't care about confidentiality, you just care about integrity, and you're sending it to someone, what key do you use when you're creating the integrity hash? And who? Oh, don't hit return yet. You have to say like senders, whatever, or receivers, whatever, and I'll tell you when to hit return. 1, 2, 3, hit return. Okay, you need the sender's private. Okay. Yeah, that's correct. You do the sender's private. And what key is the receiver going to use to see if it is if the integrity is still intact? Oh, no problem, Peter. 1, 2, 3, return. Yeah, which public? Sender's. That's. Oh, wait a minute. Hold on. Let me read this. Okay, that's right. That's right. Sender's public. Okay, now here's a problem for you. Don't hit return answer, but don't hit return. Here's the problem. How do you know the sender's public key is the correct key for the sender? Don't hit return. What solves that problem so that you know a sender's public key came from the right sender? Okay, return. Yes, exactly. Sender's authority certificate. Exactly. Okay. Similar problem. You're doing email. We're on the email chapter. Okay. This time you don't care about integrity. You only care about confidentiality. You're sending a mail from one person to another, from the sender to the receiver, and whose key and what type of key do you use when you want to send a message which is confidential? Don't hit return. 3, 2, 1, go. Oh, okay. Okay, we've got 3 answers, and it's all saying the receiver's public key. Okay, and then what are they going to do to decrypt it? Don't hit return. 1, 2, 3, go. Okay, boy, that's awesome. You got this down pat. And I'll tell you, a lot of students go through security courses and they don't know this. Okay, let's see. Okay, here's a good one. I made one up myself. For critical thinking, I'm like going deep. Now let me get a piece of paper so I explain this right. Here's what we're going to do. This is the toughest problem yet. We get a sender, and we're going to send it to a receiver. It's email. Now what I want to do is I want to make it, let's see, I want to sign the integrity, and then send it to the receiver. However, I only want the receiver to be able to know if the integrity is intact. I don't want anyone else to know. So think about that. This is going to take you maybe a minute. So I'm going to give you a little time, but think about that. I'll say it again. The sender wants to digitally sign or sign the integrity of an email and send it to a receiver, but the sender only wants the receiver to be able to check to see if the integrity is intact. So what does the sender do when sending that email to the receiver? So don't hit return. Don't hit return, okay? I'm going to give you a little time because this is a good one. I'm going to write down the answer myself. So okay. 3, 2, 1, return. Okay, that's great. King, right on. You nailed it. Let me check Peter's answer. You use a secret value that is only known by the... No. You don't have a shared secret yet, Peter. All right. Well, I hope you're not reading from the book, but I'm just thinking we don't want to assume you have a shared secret yet. Okay, you hash the entire block, digitally sign the hash, but James was right, because after you digitally sign the hash with your private key, everyone in the world can see if its integrity is still there. But James nailed it. He just said after you sign with your own private key and create the digital hash, then you take the hash and you encrypt that with the receiver's public key. That was nailed perfect. And that's a bit advanced, because I don't even remember seeing that in the book. It might be somewhere, but don't remember it. Yeah. Okay, the next thing is we need to make sure everyone understands the solution that James has presented. So if you don't, let us know, because I want to make sure you know. And then what we're going to do now is we're going to dig dig down deep into Peter's comment. Peter's comment about that there's a secret value that's known by the communicating parties. Okay, for email, that we don't do it that way. So, I mean, I'm not saying we do it that way for other things, but in general, we just don't do that for email. So, I'd like Peter to explain via text chat the following. Oh, I'm sorry, you've got a mic, so I'll give you the mic too. If you want via mic, that's fine too. Peter, could you explain how PGP works with regard to encrypting the message? Well, it's going to encrypt the message with what I'll call a session key or an email key. And then how does it get that information to the other side? So the other side knows what key was used. See, the email sender and receiver, they don't like talk to each other and create a common key. The sender creates a session or email key and then gets that to a partner in some way with the message. And then it may log off before the other one ever gets the message. So how does the receiver know how to decrypt the message, Peter? Okay, and Daniel can go ahead and answer. Oh, okay, here we go. Let's see, the encrypted message is sent together with a short key, where the receiver first uses private key to decrypt the short key, and then that to decrypt the message. Exactly. So the sender just creates a key somehow, and then takes that key and encrypts it with the public key of the receiver, and then sends the email. And then when the receiver receives it, they use their private key to decrypt that. Then they got the short key, and then they take that key and decrypt the whole message. Exactly. Okay, and you know what? What's kind of fun is I think you're learning this stuff so perfect that you could come up with your own algorithms. You may find better ways to do things. This is like research. You can look at the way different people do different things, and you can say, hey, I know a better way. But you're now at the point where you can analyze these different problems and come up with solutions. So this is a very good sign. And again, I'll tell you, a lot of security students go through a course and they don't learn these things. So this is good. Okay, well, we've been digging down deep into this email stuff. Let me grab the book again, see what else is going to be fun in here. Okay, what do we got? Oh, then there's the S-MIME. Oh my, it's a big one. That's a big one. Well, I think we'll save that for after the break. We'll stop a few minutes early today. What do we got here? Okay. Oh, I'll just show you something first. Let me try sharing my screen. So, break until 1:50. So you have 15 minutes, and what you have to do is you have to come back with some critical thinking topics, just like we've been doing. We go down deep. We look at students' different answers, and then we try to dig into that. And then also I'm going to do a little demo. Okay, we'll see you in 15 minutes. I'm going to pause the record. Okay, welcome back from the break. Hope you had a nice break. So the workshop's open now. Thanks for your help on that and letting me know about it. What next? Well, I wanted to do a little quick demo. Let me show you this nice web page. Okay, I'm going to request a share from my Z session. Assume you all have it full screen now. And I can monitor your text chat at the same time as I'm working on this. Okay, good. Now, what we want to see here, this is interesting. First of all, credit goes to James King again. He's the one who found this awesome report from the Electronic Frontier Foundation, I think, something like that. And they're into privacy. They do interesting things. But what is interesting here is look at all the red. Red means not implemented or not fully implemented. And what we see on the left is companies like Apple, Amazon, AT&T. Apple, I'll point out Apple's been hacked a few times in major ways. And the thing that I want you to get away from this slide, the most important thing is the following. Security is not easy and simple. Security takes time. And what I mean by that is, look at all these red. Now, these companies like Amazon and Apple, they have hundreds of network engineers and hundreds of security engineers, and they can't even get the security working. Can you believe that? So I want you to understand that to implement security, it's not just taking a bunch of boxes and clicking on a couple of buttons and you're done. Because if it was so easy, some of these there wouldn't be any red at any major company. And there's two, this is fun, critical thinking. We can think technology and business. So let's talk technology. Technology, there are some reasons to implement security. We have the technology to implement it, and then we have our engineers go loose and they implement a bunch of security. Even if you don't need security, can anyone tell me a non-technical reason to implement security for Apple and Amazon? You might say it doesn't make sense, but why would you do it anyway? Exactly. Why would you? Exactly, that's it. So that's an important point. I like to talk about technology, but you need to know business too. You need to know business, and what you want to do from a security point of view is you want to say to your customers, look, here's the 5 different security things. They're listed on this web page from EFF. We've implemented it all. Even if you don't need to, you just do it. And then you say, look at our competitor. Look, they can't figure out how to get the security working. Like Apple, they can't figure out how to get the security working. They don't have the right, as a competitor, you say this. They don't have the technical engineers. They don't have the business vision, and they're getting hacked all the time. Why go with a company like Apple? And then James King said corporate responsibility. So corporate responsibility might be a good one also because at least, for example, in the U.S., we have different regulations, and the regulations require the corporation to perform certain activities. Otherwise, they get sued. Yeah, compliance. They have to be in compliance, and if they're not and they get hacked, they have a big penalty. So when you're trying to get a job, that's another good sales pitch. Hey, if you don't follow things correctly with regard to security and you get hacked, you're going to have to pay $250,000 per patient when you lose their records. So you don't want to do that, so why don't you just hire me cheap for $150,000 a year? And I was making well over that when I was in the U.S. So I know what I'm talking about. Okay. Dun, 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 dun. Well, anyway, thanks again to James. There's something else I wanted to show you. And what I'm sharing now is kind of cool. If I move my mouse up to the top, I see a local address, right? It's a private address, 192.168.200.220. What that is I'm running a remote desktop session. So I'm in my office. I'm connected to the Adobe Connect. And then from that machine, I'm sharing my screen to the presenter, to my other machine, and then I'm running remote desktop, so I'm getting over to a machine in the InfoSec lab. So in the InfoSec lab, here's what I do a lot is I do this network management. And for example, here's the CDP net, that's one of the networks, and this machine right here, I'm going to click on it. That's a Cisco ASA, and that's the one I installed today for the student use. So that's the one that you can log in, you can configure it any way you want. You probably want to, from time to time, save your configuration to the flash or to your PC. And then you can just do just about anything you want. And if you blow it away, it's no problem. It's near my office. I can go back and reset it and load the initial config. So that's good to go. And what I do is I'm doing like ping tests on it, HTTP tests on it, and then I haven't set up everything because you can see here on this ASA number 1 over here, I'm running the NetFlow and I'm running SMTP. So I do all kinds of network monitoring. This is kind of cool. What just popped up on the screen is what I do is I do network management, and I do via SNMP. I log records of all the users who have logged in via a VPN. And then I can see for any time period in the past week, minute by minute, how many users were logged in. And that's going to help me understand how many ASAs I should put out there for you. I've heard that my department for the information security, we just received approval to purchase 480,000 kroners worth of equipment. And we're supposed to do some project with that. But I've put in a request for 20 of these ASA devices. But I don't want to get Kim pissed off, so what I did is I checked with my friend who works at Juniper, and they're willing to also give us a really great deal. So I'm going to compare Juniper equipment with Cisco before I decide what to do. Okay, but anyway, so that's SNMP. Here's our favorite NetFlow, where you can look at the top talkers or the connections or what protocols are being used the most, et cetera, et cetera. Okay. That's about it. So if anyone wants to use this ASA 10 to do anything they want, let me know. I'll give you a login. You can do anything you want. And then I can monitor it as well at the same time. Okay, let's see. Okay, oh, and also, I want to say James hit a good point. It comes down to profits. So what you want to do from a business point of view for security is you look at all the vulnerabilities for the company, all the equipment, et cetera, et cetera, et cetera. You figure out where your assets are. You figure out what vulnerabilities will cause the biggest damages to your assets. An asset can also be like your reputation as a company. If you're like a security company like Komodo and you get hacked like Komodo, wow, there goes your reputation. Other companies, it might not matter as much. But you do want to look at the vulnerabilities, then the assets, and the risk to those assets via the vulnerabilities. And there's another thing you have to think about before you decide what to do. What is that? We got the vulnerabilities, we got the assets. What else do we have to do? I know it's not technology, this topic, but I think it's important. Resources, yeah, well, you can always get more resources, right? It's just a matter of money. So you look at the vulnerabilities, you look at the assets that are going to attack. What other information do you need to make a business decision? Threat, yeah, threats. Value of assets, yeah. And keep going. You have to think about the threat, the value of the asset. Exactly. What else? A couple more things. Not many. I'm just asking for the basics. Likelihood of attack. Exactly. You want likelihood of successful attack. That is extremely important. Because if the likelihood of a particular attack is only 1% per year, you're not going to invest as much money for that as something similar that the chances are 90%. So very important. So you look at the vulnerability, the likelihood of attack. If the attack is successful, what is the cost of assets that are lost? And the probability is very important. And when you have all that information, then as a business decision from the top level management, who hopefully has some security knowledge, they go down to the technical folk and they say, technical managers and technical engineers, here is what you're going to be doing. You're going to be implementing this security feature and functionality, and here's money for it. Here's a pile of money. and here's what you got to do. Here's another pile of money, and here's what you're going to do. Here's another pile of money, and here's what you're going to do. What happens if you don't have management taking those steps? What are the engineers going to be doing? I know what I would be doing. Come on. What would you be doing? Would you just say, oh, I don't know what to do. I'm going to do the management job for them and then figure out what to do? Yeah, you'd use the money on technical stuff, but what would you do? What kind of technical things would you implement from a security point of view? Come on, common sense. Think of children. What do they like to do? Three. Testing. Oh, come on, do better than that. What do kids like to do? Okay, I'm going to tell you. Yes, they like to play. Kids like to play. So, okay, I should probably pause the recording, but let me tell you. If I was an engineer, a security engineer, and I was working at a company, and they didn't have any good management at the top telling me what to do, I would perhaps work on all of the technical security projects that I thought were the most fun and more interesting, and perhaps I would work on things that would help me in my future career and help me get a higher paying job, help me get a job at another company. And perhaps all of those activities I do have absolutely nothing to do with a business-wise decision. So I want you to get away from this, that you should think that the technical people, the technical managers, and I'm talking practical technical skills, and the engineers, what they're going to do is have a bunch of fun and do anything they want until such time as you have some smart top management who say, we're going to figure out what the vulnerabilities are, the assets and the value, the probability of the risk, the cost of the loss. And then, based on that, we're going to mitigate those risks by telling the technical folks exactly what they need to do. Now, you don't have to tell them you're going to do a VPN with 256 bits of AES encryption. That would be for the technical folks to decide. What you would say is you want super duper high security between these two sites, and then you give the engineers a pile of money and you say, this is for your salary and for some software and hardware, but this is what you have to do and this is when you have to do it. Yeah. Otherwise, the technical folk are just going to have a great time doing anything they want. So I'm trying to teach you how to manage technical folks. I don't like it because I don't want to be managed if I'm technical, but you need to know. And hopefully you learn those things in the program, like in your introduction, information security course, etc. Yeah, exactly. They'll buy expensive gaming equipment. Exactly. And you know what? They will just buy anything they want. They're going to have a great time, and they're going to focus just learning and having a great time. Oh, well, I think I've killed that story, so we're going to have to move on. 207. Back to the topic. So, okay. What did I want to show you? Okay. Well, I showed you the lab. You can of course make that share screen very small now. Let me see, is there anything else I want to show you? And again, next week it's going to be really fun with IP security. IP security. Okay. Oh, back to the relatives, James. Okay, good. People are moving around. Okay, let's see. I was talking about SMIME a little bit, and they have all kinds of stuff. So they've got the version number, the type, and then transfer encoding. The idea is not everyone speaks the same language. We have all these different languages, and they're encoded differently. So MIME has encoding built into it. You can have descriptions of the content as well. And you can have like nested messages, which is interesting in MIME. One message inside another message. You can create a plain text or an enriched message. Normally, by default, everyone's creating enriched. That's really common. And I've written a program I've written a program to actually send email. So when I've been sending you email, some of the time I've written a program to do it so I can go through, send everyone a little customized email and have different information based on their status. So what's neat is I'm programming against some of this MIME functionality. And you can do everything you can do with email, you can do programmatically. You can include files, for example, include pictures, change the encoding. Okay, and for MIME, you can have signed data with a digital signature. And there's different ways to indicate that you signed it. Sometimes you'll get a message and it's PGP hashed, and you'll see that within the message itself. If you wanted to, you could take the message and compute PGP yourself and then compare. But what we really want is built-in functionality in the application, so you can just click. And with Microsoft Outlook, for example, they have that. It's built in. You can take another person's public key, stuff it into the contact. That's how you do it. You go into your contacts, you create a contact with an email address of your friend, and then in there you can add a public certificate. And there's two ways you can add it. You can just add it yourself, or they can email it to you, and then you can add it that way. And then when you receive messages, you can see if it's digitally signed and if the integrity matches. Can anyone guess of one problem with these email keys? Well, the problem is like when the digital signature or certificate expires, then it's not going to look good. So we kind of have this issue. We're going to be saving the email for 10 years, and certs are going to run out in one. So it'd be nice to have a solution to that. And that's, for example, a research idea. You might be able to create a really nice research solution to that, so that even if someone has old keys, it can get, for example, converted automatically to the new keys. Okay. Hopefully that makes sense. The idea is you've got all these old emails and you want them automatically updated. So, for example, you take the old key, you look it up in their domain has an entry for a newer one, and your software could automatically decrypt the old message and encrypt with the new key. That's just an example. Okay, but we're not there yet. So in the meantime, we got a big mess to deal with. Okay, and we have all these abbreviations. Boy, we have a lot. We have PKCS as well, and what it is, it's a type of key, and that key can have different formatting. It has this S-MIME format, that's one way, but you can also run, for example, from Linux, you can create your own keys, and you can create that PKCS format, and you can convert it. What is interesting here? Okay. Boy, question to you. Everyone type the answer, but don't hit return. Okay, don't hit return. Here's the question. Okay, what is the most popular public key certificate format? It starts with an X. One, two, three, return. Oh, yes. Good work. It's good. I really like X509 because it's like the ruler. It's like that's the only choice. So that's good. Oh, yes. Yeah, and here's an interesting feature of S-MIME. To have a signed receipt, you want to have receipt proof that they have opened the email or whatever. And you want a cryptographic proof that you can take to court. And they have that feature listed there. Does anyone know how to do that ahead of time? Now, I know you might know how to get receipts, but I'm saying cryptographic signed receipts. because I know how to do it. I've been doing it for years. So you send an email. You want to have something you can go to court with to prove that they opened the email. So you need some kind of cryptographic solution. And they're going to have it Nestmine, but it's not here yet. So what do you do today? Okay, it looks like no one knows the answer. So I'm going to give you the answer. ReadNotify.com. Yeah, you pay them a little bit of money, and what they do is they take email, and if I want to send all my students email and have a digital certificate showing that they opened the email, then what I do is I send those emails via that service. They take my email, and then they will insert some spyware, and the spyware they insert, and it's good for you to know how this stuff works. They do like an HTTP within the email message, and that HTTP is going to go to their site, and it's going to have some kind of like long identifier which will indicate that it's a mail I sent. Every single mail I send will have a different signature or a different serial number, you could say. And then the HTTP goes to their site, and then if they get that, then they know that someone has opened up a message with that particular HTTP address. And then they go and they harvest all the information they can from the client browser, like they're going to grab the IP address and what time and all kinds of information. And then they put that in and they sign it, and they have a digital signature of that information, and they give it back to me. And then if I had to, I could go to court, and that would help me prove that someone has opened up that email message. So that's an interesting thing. And it's important for you to know that that's how the spyware works in email messages. When you open up the email so that, so you can display pictures, for example, then they have all these hidden HTTP requests which will go to a certain site and do a certain thing. Now, the way you can spot it programmatically is the HTTP request. It's not going to like request something and fill up a page. It's going to be so small, it's going to be like a little dot on your screen. That's as much information as it's going to have, or no dots. So you can programmatically look for things like that in the email, where it's going to do an HTTP request to a very small window size. Okay. So Daniel says, how do you know they have sent the email to us? You don't know they sent it, but they tell you they sent it. You kind of have to trust them, but that would be a problem, Danielle. That's actually good critical thinking. If something went wrong with their system and they didn't send it, then we would never know if it's sent. But even if it's sent to them, we don't know they opened it until they open it and they say they will accept pictures. And if they do that, that's when we have some proof for court that the document has been opened. And if you're interested in that kind of stuff, you can always go to their website and check it out. Let's see. We're back to domain. Well, that's about it. So we've covered the whole chapter, a little bit here and there, and we're out of time. So any other topics you want to talk about real quick, or are we done for the day at 2:30? Oh, glad you liked the session. Sorry about the domain key not working. That's too bad. And remember, I've got an ASA. If anyone wants to use it, just send me an email after class, and I'll give you the credentials to get in. You can do anything you want. And right now, there's one available for students to do anything you want. And I'm looking around my office, and I've got at least one or two more that I'm going to put online real soon. Okay. And what's really cool is with these routers, there's a whole bunch of documentation on learning firewalls and VPN, everything in the world. But then you can also do things like run OSPF and RIP and eGRP routing protocols between them. Oh, I'm glad you liked the session. Is it correct that the deadline for next week's chapters is on Monday? Okay, let's see. Let me make sure I'm on the same page. Okay, I've got my document open, and here we are. Okay, so for next week's chapter, and next week's chapter is, okay, here we go. Yeah, we got 2. Okay, so for next week, starting on the 16th, I have chapter 9 and 10, and I don't have any workshop. Let's see. Well, why don't I just say this? The deadline for next week's chapter, and next week is the 16th until the 20th. 20th is a Friday, and then the due date is the following Monday. So I think that's the 23rd. So that would be correct. No, you don't have any classes, but you have homework, and you also have to listen to my lectures that I'm going to create on chapters 9 and 10. So you have no classes, so I won't be here talking, but you do have homework, everything else. Yeah, that's not so fun. And a lot of you have exams as well. A lot of students in the class have exams as well. And that's why the lectures were canceled, but we still have a lot. So here's what I'm going to do, though. I'll make you a deal. If you want, I'll help you one-on-one with the ASA security. So to learn about VPNs and that stuff. And there you go. And that's about it. Otherwise, we are over time, and I'm going to stop the recording now. Thanks for listening, and thanks for coming. Yeah, Danielle, you can... I'm available... Well, send me an email. I'm available